Alright, so today we're going to learn how to evaluate limits algebraically. And this is especially important if you're not given a graph or a table like we have been given in the past to find your limit. And you're just given a limit problem and you're asked, find the answer. So let's go ahead and go through some problems so that we can learn the skills we need to evaluate limits algebraically. So our first example is the limit as x goes to 0 of x cubed minus 2x all over x. So the first thing I'm going to do is try a direct substitution. So I'm going to plug in my 0, which is right here. X goes to 0, so that's why I'm plugging in a 0. So I'm going to have 0 cubed minus 2 times 0 all over 0. This is going to give me 0 over 0, which is called an indeterminate form. So this is an indeterminate form. And what this basically means is that we have to do more in order to find out what this limit is. 0 over 0 is not 0, it's not 1, it's not anything. That's why it's indeterminate. It's indeterminable what this answer is. So we need to do more in order to find out what our limit will actually evaluate to. And one strategy we can use is actually factoring. So we can factor out our numerator and our denominator and manipulate algebraically whatever's inside our limit and see if we can cancel out any common terms from the top and the bottom so that we won't have a fraction anymore and there's no way we can get this indeterminate form, and then we can just plug and chug and see what our limit is. So I'm going to rewrite my limit. So I have the limit as x goes to 0 of x cubed minus 2x all over x. And the first thing I notice is that my top numerator is factorable. So I'm going to have the limit as x goes to 0, and I can factor out a common term of x from our numerator. So I have x times x squared minus 2, and our denominator is x. And then we've accomplished our goal. I can cancel out these x's. And so I have the limit as x goes to 0 of x squared minus 2. And plugging in 0, we just have 0 squared minus 2, which will give me an answer of negative 2. So that's our first strategy. Our strategy was, first thing I'm going to do is do a direct substitution. That didn't work because we got an indeterminate form. From there, I went into our numerator and I factored it so that we could cancel out a common term between the top and the bottom of our fraction. And then from there, I could just plug and chug and I'd get a nice clean answer of negative 2. Let's try the same strategy on our next problem. So our next problem is the limit as x goes to 1 of x squared minus 1 all over x minus 1. Now to do this, we're going to first follow the same process. We're going to plug in 0, or sorry, in this case 1, and see what we come up with. So we're going to have 1 squared minus 1 all over 1 minus 1, which will reduce to 0 over 0, again, that indeterminate form that we think is ugly and we don't like. So the first thing we're going to do is factor out our numerator. So we're going to have the limit as x goes to 1 of factoring out our numerator. We notice that this is a difference of squares. If you don't know how to factor differences of squares, I would review some algebra before you come back to this video. So factoring that out, we can see that that's going to be x minus 1 times x plus 1 all over x minus 1. And again, we have a common factor of x minus 1, so these two will cancel out. And so we're just left with the limit as x goes to 1 of x plus 1. And plugging in our 1, we get a nice clean answer of 2. So again, we first did a direct substitution. Indeterminate form didn't end up working out for us. So we factored out whatever we could factor out, canceled out terms from the top and bottom, and then from there just plugged and chugged. Now on to our next example. This example seems a little bit more intimidating because there's natural log in there and e, but it's really the same process. So first, again, we're going to plug in e and see what we get when we do a direct substitution. So we're going to have ln of e squared minus 1 all over negative ln of e plus 1. Natural log of e is just 1 because e to the first power is 1, or e to the first power is e. So we're just going to have 1 squared minus 1 all over negative 1 plus 1, which is 0 over 0, that indeterminate form. So now let's go ahead and see if we can factor this. And just looking at it, I don't think it looks factorable. It doesn't really stick out how we can factor this, but upon closer examination, you can see that it's actually factorable. The numerator is factorable because it's a difference of squares. ln x squared minus 1 is the same thing as saying ln x squared minus 1 squared. So our numerator is actually going to end up factoring into ln x plus 1 times ln x minus 1. The same way in our previous example, x squared minus 1 factored out into x minus 1 times x plus 1. So rewriting our limit with this in our numerator, we have the limit as x goes to e of ln x plus 1 times ln x minus 1 all over negative ln x plus 1. Now here, it doesn't seem obvious that we can cancel anything out, but you can actually factor out the negative on your denominator and then get a common factor. So this is going to be the limit as x goes to e of ln x plus 1 times ln x minus 1. And factoring out the negative sign from our denominator, we have negative times the quantity ln x minus 1. And then from here, we see that we have these two terms, ln x minus 1, that will cancel out. So we're just left with the limit as x goes to e of ln x plus 1 over negative 1, which will give me 1 plus 1 over negative 1, or yeah, 1 plus 1 over negative 1, which will give me negative 2 as my answer. Now let's go to the next example. So the next example, normally you would do a direct substitution, but actually when you do a direct substitution, this ends up being 0, which is not an indeterminate form, and you would just call that your answer at the end of the day. But there's an important skill you can learn from doing this problem in a different way, which is polynomial long division. So again, the first thing I'm going to do is try to factor out my numerator. So this time it's not a difference of squares, but it's still a factorable quadratic that we can easily manage. So we have the limit as x goes to 2. And to factor out my numerator, I'm looking for two numbers that when multiplied together will give me positive 4, and that when added together will give me negative 4. And those two numbers are negative 2 and itself, because negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. So the top actually factors out to x minus 2 whole squared. And then we still have our ugly denominator, which upon first glance doesn't really seem factorable because it's x to the 4th, x squared. It's not really clean. So what we want to try to do here is try to see if x minus 2 will actually go into our denominator. If that's the case, then what we're going to have in our denominator is we're going to have x minus 2 times some other polynomial. And then we can actually cancel that out with our x minus 2 squared in our numerator, because these two will cancel out, and we'll just have x minus 2 over whatever that leftover polynomial was. And then from there, hopefully we can just plug and chug from there. So the way we do that is we divide out our denominator and x minus 2 using polynomial long division. So I'm just going to make a little note here. Note. So we're going to divide out our denominator and x minus 2. So we're going to see x minus 2 goes into x to the 4th plus 0x cubed minus 3x squared plus 0x minus 4. These 0 don't change the value of the function, but I like to write it that way because when you do polynomial long division, it's sort of easier to see which term will go where when you write out every single term, even though it may not be included in the fraction, or in the polynomial, my bad. So dividing this out, we're going to have x to the 4th over x, which is x cubed. And then we're going to have x cubed times x is x to the 4th. X cubed times negative 2 is negative 2x cubed. Subtracting this out, these two will cancel out, and we're just going to have a positive 2x cubed. 2x cubed divided by x is 2x squared. So we're going to write that out. And then we're going to bring down this negative 3x squared. And we're going to have 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. These 2x cubes will cancel out, and we're going to have negative 3x squared plus 4x squared, which will be just x squared. And then from there, we can bring down this 0x. X squared over x will give me x. And then multiplying it out, x times x is x squared. X times negative 2 is negative 2x. And then we can cancel out these x squareds, so we're going to have 0 plus 2x because we have a negative 2x. So 0 plus 2x is just 2x. And then we're going to bring down this minus 4. 2x over x is just 2. So we're going to multiply the 2. 2 times x is 2x. And 2 times negative 2 is negative 4. So then subtracting it out, the 2x's will cancel, and then we're going to have negative 4 plus 4, which will give us 0. So what we learned from doing this is that x to the 4th minus 3x squared minus 4 is the same thing as saying x minus 2 times x cubed plus 2x squared plus x plus 2. If you were unsure about that whole process of long division, make sure you go brush up on those skills because it's pretty important when you come to calculus. So go brush up on that, and then hopefully you'll be able to understand once you replay that part. So now I can write my denominator in this way because that's what we found out when we did our long division. So I'm going to have the limit as x goes to 2 of x minus 2 whole squared divided by this whole thing, which will be x minus 2 times x cubed plus 2x squared plus x plus 2. And then from here, I can cancel out some terms. So I'm going to have one of these 2x squareds that's going to, or sorry, x minus 2's that's going to cancel out. And then this x minus 2 on the bottom will cancel out. So I'll have the limit as x goes to 2 of x minus 2 on our numerator. And then our denominator is going to be x cubed plus 2x squared plus x plus 2. And then by doing a direct substitution here, we have 2 minus 2 over 2 cubed plus 2 times 2 squared plus 2 plus 2, which will give me 0 over 8 plus 8 plus 4, which will end up being 0. And remember, our direct substitution at the beginning showed us that our answer should be 0, so this is correct. So there's two main ways that you deal with limits algebraically. You factor out your numerator and cancel out common terms, or you do polynomial long division and see if that will allow you to cancel any terms between your numerator and the denominator, and hopefully that will let you reduce your limit and get rid of any indeterminate forms you may have. And we're done.